Continuing with our review, this is problem number 7. On problem number 7, we're being asked to solve. So our goal is to find the values of x. The first thing to notice is that we have sine of x and cosine squared of x. Unfortunately, it's very difficult to combine these two unless we transform the cosine square into sine. So I will transform this and say it is 3 minus 3 sine of x minus 2 times, instead of cosine square, I'll write 1 minus sine squared of x. And this is still equal to 0. Now, I can rearrange this. Notice that the negative 2 times the negative 1, or I can distribute this negative 2. That would be negative 2 plus 2 sine squared of x. And I still have the 3 sine x here and the 3 here. Now, let's combine like terms. I have the 2 sine squared of x minus 3 sine x and plus 1 is equal to 0. Well, this looks like a quadratic. Which quadratic? Where I have 2x squared minus 3x plus 1 equal to 0. And if I want to factor this quadratic, I'm using the shortcut. I know that I will have 2x and x here. I need a 1 as a product and a negative 3. Is it 1? That'll be my, this one should be, that'll be my negative 2x, negative another x, positive 1. All right, equal to 0. Well, I can rewrite this one and now take it back to 2 sine of x minus 1 times times sine of x minus 1 is equal to 0. Well, I will solve them separately. If I solve this part, I will end up with sine of x is equal to 1/2. Compared to this portion, I will have sine of x is equal to 1. Well, I will solve them separately. Let's start with this. This one will give me x is equal to the sine inverse of 1/2. It's positive, opposite is 1. So the PV here is, since we're talking about x, I will say pi over 6. PV being pi over 6, I will say x is equal to pi over 6 plus 2 pi n, or x is equal to pi minus pi over 6, which is 5 pi over 6 plus 2 pi n. Let's solve the second portion. Sine of x equals 1. That means x is equal to the sine inverse of 1. Well, 1 is located on the axis. For the sine to be 1, I need to be somewhere here, where the coordinates are 0, 1. So this one, I will say x is therefore equal to pi over 2 plus 2 pi n. On the review, I believe it's asking you to find all the values between 0 and 2 pi. Since we're looking for the values between 0 and 2 pi, the first value will therefore be pi over 6, which is this value. I will also have pi over 2 and 5 pi over 6. Those are the values that I see so far. For problem number 8, I have 4 cosine squared of theta is equal to 3. So what I will do is, I will say divide by 4 to get cosine squared of theta is equal to 3 over 4. Now, if you're familiar with this, you know that you can factor it by saying, well, this is equivalent to cosine theta plus square root of 3 over 2 times cosine of theta minus square root of 3 over 2. That's one way. Or you can just say cosine of theta is equal to plus or minus square root of 3 over 2. Either or is fine. I believe it's easier to forget the sign on this one. So if you can factor, that'll be your best route. All right, from here, I will split it in two. So I will solve the case where cosine of theta is equal to square root of 3 over 2. And I will also solve the case where the cosine of theta is negative square root of 3 over 2. Now, in case it's square root of 3 over 2, you will have the adjacent is square root of 3. Therefore, the PV for this one, let me write it in red. The PV for this one with the adjacent of square root of 3 will be pi over 6. Compared to this one, the PV being, since it's negative, it's not going to be pi over 6, but 5 pi over 6. All right, from here you can write theta, by the way, it's supposed to be 30 degrees and 150 degrees because we're talking about theta. So theta here is equal to 30 degrees plus 360n, or theta is equal to negative 30 plus 360n. On this one, I will say theta is equal to 150 plus 360n, or theta is equal to negative 150 plus 360n. All right, from here, I can find all my solutions. Remember, we're going from 0 to pi. The smallest value seems to be 30. I'm getting it from this equation. Well, I used this equation and got 30. I will use this equation here and get 150. If I use this one and I plug in 1, I will get 330. That's using this equation. And the last equation, if I also plug in 1, I will get 100 and actually 210. Those are the only solution you can get between 0 and 2 pi, or between 0 and 360. All right, I'll move on to problem number 9. This is similar to the previous one, but this time I have 1/2 instead of square root of 3 over 4. Well, I divide both sides by 2 first to get cosine square of x is equal to 1/4, or x is equal to, cosine x is equal to plus and minus 1/2. You will solve them separately. In case the cosine of x is equal to 1/2, and the case where the cosine of x is equal to negative 1/2. It is very similar to what we did on the previous one. Well, the adjacent is 1, so the PV here is, and since we're talking about x, I would say PV is equal to pi over 3. And here the PV being negative is equal to not pi over 3, but 2 pi over 3. Where x is equal to pi over 3 plus 2 pi n, and the other one is negative pi over 3 plus 2 pi n. And this one will be 2 pi over 3 plus 2 pi n, and negative 2 pi over 3 plus 2 pi n. Let's go ahead and find the solutions. The solution will be, the first one seems to be pi over 3. I will have also 2 pi over 3. In case I plug in 1 here, I'll have 2 pi or 6 pi over 3 minus pi. That will give me a 5 pi over 3. And in case I plug in 1 here, I'll have 6 pi over 3 minus 2. I'll also have 4 pi over 3. And those are your solution between 0 and 2 pi. Number 10 is a very interesting one. First of all, this looks familiar to the sine of 2x. However, sine of 2x is 2 sine x cosine x. So my goal is to have, instead of negative 4, I would like to have 2 sine x cosine x. But to have 2 sine x cosine x, it requires me to divide everything by negative 2. So if I divide everything by negative 2, I end up with the square root of 3 over 2 with a negative in front. Well, now I can say this is the sine of 2x, that is equal to the square root of 3 over 2, of course negative. So I can now say that 2x is equal to the sine inverse of negative square root of 3 over 2. All right, opposite is square root of 3, hypotenuse is 2, and this is in the 4th quadrant. So I can say that the PV, feel free to graph your triangle, but I can say that the PV here is negative pi over 3. Now, since the PV is negative pi over 3, I would say 2x is equal to negative pi over 3 plus 2 pi n. or 2x is equal to pi minus negative pi over 3 will give me 4 pi over 3 plus 2 pi n. So at this point, I will just divide everything by 2 to get x equals negative pi over 6 plus divide by 2 is pi n, or x is equal to, if I divide by 2, I end up with 2 pi over 3 plus pi n. All right, let's go ahead and find the solution. Well, negative pi over 6 is not one of them. I plug in 1 and I get 5 pi over 6. If I plug in 2 here, I get 12 over 6 minus, I get 11 pi over 6. On this one, 2 pi over 3 is one of them. In case I plug in 0. In case I plug in 1, I will have 5 pi over 3. If I plug in 2, I will pass 2 pi. So these are the only solution between 0 and 2 pi.